My turn.
Right now, I'm working on the arena.
Yeah, I'm gonna start the monsters now. The best, it's best at the stairs. From there, it's downhill.
Alright, go. Okay, so okay, so for the plan for our arm, the main problem was there wasn't a plan. We just kind of started building. All we knew is we wanted to use the pulley because then we didn't have to use as big of a counterweight, so that works really well. That was pretty much it. We just thought of ideas as we go.
We started like our basic idea was like to uh, replicate the arm. So we would have a tower holding it together. This we would have a motor here and a motor here. When all the joints were in place, we made the final program and tested the arm. Noah was the programmer. I had the hardware. The arm didn't work at first couple of tries, so we started debugging the program and making modifications of the arm. Since we have no sensors, we had to time everything, like Ken did. Um, we incorporated pulleys, as you can see there, to raise the cup, to lift the weights at the top.
And then rolls. Okay, so we were successful in making the robotic arm that can pick up the cup. The problem was making the upper arm able to lift the weight of the rest of the arm, so we had to use a counterweight for that. And then the main obstacle was the hand. We had to try a couple different designs before we finally found one that would actually work. And then the problem was we had to make the timing perfect, and as you can see, it's still not perfect. We have to make sure it's in the exact right spot before it'll work.
And having a pulley, every time we put it back into its normal position, we don't know how much it's going to go down or up. It's trial and error, but like for the Mindstorm, you can like find the perfect position.
So like, if we were to do it next time, we'd probably use a motor to power the thumb. And our hand, we kind of got lazy and didn't want to keep cutting metal. So we have some excess metal sticking out of the side of our hand that isn't interfering with anything, it just looks kind of weird. So if we were to make improvements, we'd use a motor on the thumb and we'd cut off some of that excess metal. We'd also probably make the fingers longer, so it wouldn't have to be in such a perfect spot to pick up the cup.
The main lesson we learned is to plan before we start. And another big problem was group communication. Because me and Noah didn't get to get along very well together. So an improvement could be like communicating better, listening to other people's ideas, and get more organized.
Alright, so the Lion Robot is me and Ryan working together. In the project, we need to build a robot to drive search into a room, telecom beacon. We worked on the project, but we really didn't have any kind of planning. It was mostly programming, so we kind of wrote whatever we thought would work and tested it out. And attempted to debug whatever happened, which usually involved just getting help from our peers.
So robot this problem is good, but we did it, and we used, I guess, a linear logic, and we used a C/C++ programming. A program has used problems such as getting stuck in the virtual region at the beginning, but now it's bouncing around it. It also has the ability to find the way out because I guess right now it's just vector and randomly until it just does find the way out. And we try to solve these using the manipulating code that Ryan gave us.
If you were to try to plug it in, we would probably do project by understanding the more, so we can actually know like what these problems are mean and like how we can manipulate it to make it more effective and more accurate, and hopefully less buggy. Also, we would try to plan so we won't have extraneous code. Like there's a lot of time where
actually planning anything first.
Yeah,
Um,
first of all, the manual. We had the manual, so we built it exactly specification. But that didn't really work out, and so we took it apart, and then we started with the four-wheeler then. So that's in the next slide. But so yeah, our plan was to build it, program it, and then debug it.
okay, so our main idea with this project was trial and error mainly. After we got our final design done, we programmed, and main problem was to pass the cinder block, so we tried to get the timing correct to get back to the line after we passed it.
So the first model was the four-wheeler design. The greatest challenge is trimming, as you all know. It takes forever to turn. so we realized this, and so Model 2 had it had three wheels, the small one in the back. It solved the problem of turning, but suddenly we were having problems with following the line, going down the stairs, and traveling in a straight line. So and I was getting stressed. I was starting to sweat a little bit because we were running out of time. So we decided to go back to Model 1 and try to see if we could solve the turning problem.
Okay, so obstacles. One of our major obstacles was bringing in how to work the programming so that the robot would follow the line and pass the immovable obstacle and then get back to the line. We obviously didn't fix that correctly. Another problem was with our second model. We tried to build a spinning wheel to put on the back of the robot, and we ended up scrapping that model anyways. Let's see. The third model, our largest obstacle was getting the steering to work because it wouldn't steer. So
one wheel is not properly touching the ground because some alignment problem or something like that. So not yes. Sorry, that one. Yes. One of the wheels is not properly touching the ground because it doesn't have enough traction. So that's why steering is really hard. So me and Alex switched off with building and programming. So we learned that. We collaborated with the other groups, see what they were doing correctly and what we were not. So yeah, how to program using Mindstorms. I'd used Mindstorms before, but not to this level of detail. And yeah, that's really cool.
okay, so how would we start the project differently? First, we would think about our structure before we actually started building. Like at the beginning, we looked straight at the manual and just built from that. But then we figured out that it wouldn't work. Let's see. Second, we would draw the design while we were thinking about it, and we would plan out the robot programming more using a flowchart.